Welcome to this tutorial on Numpy. These are table of contents. We'll start with introduction to Numpy, then explore different ways of creating arrays. We see how to create array using single elements, using list or list of lists, using arange and linspace methods. Then we'll move on to the concept of array dimension, array attribute. Then we see how to select element from array using indexing and slicing. Then finally we look at the mathematics and statistics with Numpy. Welcome to this section on Introduction to Numpy. The word Numpy stands for numerical Python. Numpy is a Python package that you use for data preprocessing and analysis. It is widely used in the data analysis community because it makes working with multidimensional arrays possible. It was created by Travis Oliphant and a host of other contributors in 2005. Numpy is an open source project, so it is free. Numpy is written in Python, but partially in C or C++ in those areas where fast computing is required. Benefits of using Numpy. It makes data preprocessing and analysis easier. It has mathematics and statistical functions which help us in solving numerical and engineering problems. You can create your customized machine learning algorithms from scratch using Numpy. It is the backbone for the creation of other libraries like sklearn and pandas. Numpy is a library for working with arrays. So what is an array? An array is a data structure. It is a collection of items, values, elements, and you can access these elements using their index. The array can only contain same data type. If an array has one dimension, it is called a linear array or a list. But if it has two dimensions, it is called a table. What is a dimension? A dimension is the direction or the axis of the array. An array with only one axis is a one-dimensional array. Example is a list. An array with two axes is a two-dimensional array. Example is a table. What are the differences between Python list and an array? List can store different data type, but array can only store elements of same data type. Array require less memory than list. Array is faster than list. These are the three I can cover, but there are lots of differences. So see you in the next section. Since we are done with the theory, let's see how to import Numpy. To import Numpy, we use import Numpy. We can simply import Numpy like this, but for ease of use, we import it as np. We can import it as n, as p, as anything, but most data scientists and analysts import it as np. Now let's see the version of our Numpy. To see a version of our Numpy, we write np dot underscore underscore version underscore underscore. So the version of our Numpy is 1.19.5. So let's see how to create array. To create array, we use np.array. We can create array using single element or using nested list. Let's want to create array that has 4 as its element. We can pass in 4 here and let's call it A. So we have created an array that has 4 as its element. Let's create an array that has 3 as its element. So we have created an array that has 3 as its element. Let's create an array that has A as its element. So we have created an array that has A as its element. Let's create an array that has a list of 1, 2, 3 as its element. 1, 2, 3. So we have created an array that has 1, 2, 3 as its element. Let's create an array that has A, B, C as its element. So we have created an array that has A, B, C as its element. Now let's create an array using list of lists. So we have created an array using list of lists. We can create an array of a specific number. Let's say we want to create array of zeros, we can use np.zeros. Let's say we want it to be 3 by 3, that's 3 rows and 3 columns. So we got array of zeros. You can also create array of ones by replacing this 0 with ones. So you got a 3 by 3 array of ones. You can also create array of other numbers by using np.full. We pass in the shape to specify the number of rows and columns you want. Let's say you want 3 by 3. And then fill value, the value you want to fill. If you want to create array of nines, so we got array of nines. What we want to create array of 99, so we got a 3 by 3 array of 99. Now let's see how to create array using linspace. To create array using linspace, you use np.linspace. The linspace is very similar to the arange method, but the only difference is that the linspace can return the endpoint. Now let's say we want to create array between 1 to 13. The 1 will be the starting, while the 13 will be the endpoint. So we got elements from 1 to 13. Now by default the linspace return 50 elements, but what we don't want 50 elements, what we want 20 or 10 or 12 elements. We can actually do that using the parameter num. In this case I want to return 13 elements. So we got 13 elements. But if you look at this, you see that these numbers are floats. But what if I want them to be integers? So I can do that using dtype to specify the data type. So I specify it to int. So we now got integers. We can create array using the arange method. To create array using the arange method, we use np.arange. The arange method takes in 3 numbers: the start, the stop, and the step. The start is the starting number, while the stop is the endpoint. The step is the interval. We can specify the kind of data we want our array to return by using the parameter dtype. Now let's do an example. Let's say you want to create an array that has numbers that range from 0 to 10. So the starting point will be 0, the end will be 11, and the step will be 1. Why I use 11 instead of 10 is because the loop is going to stop before the 11, so it will stop at 10 before the 11, so it will return everything from 0 till 10. If you have worked with range, this is very similar to how range works. So let's run this. So we got 0 till 10 and the 11 was not returned. Now we don't have to specify this 1 and 0 because the default start is 0 and the default step is 1. So let's remove this. If we run this now, you see that we'll get the same outcome. So we got the same result. Now let's do another example. Let's say we want to create an array that has 5, 10, 15, 20 as its elements. Now to do that, we can mistakenly use 5, 20, and 5. If we do this, we are going to get 5, 10, 15. We will not get the 20. Now let me run so that you see what I mean. So we got 5, 10, 15, but we want to get 20. The loop actually stopped before the 20. So how do we get 20? We can get 20 by increasing this by any value. Let's just increase it by 0.1. So if we run this now, you will get 20. So we got 5, 10, 15, 20. But you see, these numbers, this array return float. What we want it to return integers. The reason why it return float is because it just pick this by default and then apply it to the array. Now what we want it to return integers, so we can specify that using the dtype. Say dtype equals to int and run. So we got integers now. Now let's do another example. Let's say we want to count backwards. So we want to create an array that has elements from 20 till 4. So the starting point will be 20, the ending point will be 3 since we want to stop at 4, and the step will be -1 since we are counting backward. So we got array that consists of elements from 20 till 4. We have explored different ways of creating arrays. So now let's look at the concept of dimensions of array. You see, if you create array with a single element like this, you end up creating an array that has no dimension. It is similar to a point. A point does not have any dimension. If you create array with a list, you create a one-dimensional array. If you create array with list of lists, you create a two-dimensional array. A two-dimensional array is made up of one-dimensional arrays. If you create array with list of lists of lists, you create a three-dimensional array. A three-dimensional array is made up of two-dimensional arrays. If you look at this, a two-dimensional array is created using list of lists, and this list of lists turns out to become the element of the list, which is used in creating a three-dimensional array. So that's why two-dimensional array is an element of a three-dimensional array. You can specify a number of dimensions you want to create using this word ndmin. Now you don't need to create list of list of list of list. You can just specify a number of the number of dimensions you want to create using this word. So you can just specify, let's say you want to create 5 dimensions using this simple list. So with this we can create 5-dimensional array. So we create 5-dimensional array. We can create 6-dimensional array by just specifying 6 here. We have 6-dimensional array. So far we have learned how to create arrays of different dimensions. So now let's look at array attributes. And the attribute you're looking at are those that will help us to get understanding of our array. I've created these 3 arrays to help for explanation. So what we want to get a number of dimensions of our array. So first we write the name of the array, then dot ndim. This ndim is the attribute that will help us to get a number of dimensions of our array. Let's say we want to know a number of dimensions of a1. Let's run this. So we got 1. So a1 has 1 dimension. Let's say a number of dimension of a2. So a2 has 2 dimensions. Let's say a number of dimensions of a3. So a3 has 3 dimensions. Now let's look at another attribute called dtype. So what dtype does is that it returns a data type of any array. So let's see the data type of a3. So we got int64. So a3 has int64 as its data type. Let's see the data type of a2. So a2 has float64 as its data type. Now let's look at dot shape. What dot shape does is that it returns a tuple, and the tuple represents the size of axis or the size of each axis. As for a2 is a 2-dimensional array, so it will return 2 numbers, and one of them will represent the row and the other will represent the column, or one is going to represent the x-axis and the other is going to represent the y-axis. Let's run this. So it returns 2 and 4, so we have 2 rows and 4 columns. Now let's see the shape of a3. So we have 2 by 2 by 4. Now let's look at another attribute, size. What size does is that it returns the total number of elements present in an array. So let's see the size of a1. So we got 4, and if you look at it here, you look at this, the number of elements present in a1 are 4. Now let's look at the size of a2. We got 8, and if you count the number of elements present in a2, there are also 8. Let's look at the attribute nbyte. Nbyte is an attribute that returns the size of an array in byte. Now let's look at the size of a2 in byte. We got 64. Let's look at the size of a1. we got 32. Now, you may not understand how nbyte works or how we return this 32. Nbyte works based on bit to byte conversion. We must have learnt in school that 8 bits equals to 1 byte. Now, if you look at the data type of A1, you see that is int64. This int64 means 64 bits. So if 8 bit equals to 1 byte, what will 64 bit equal? Let's say it will equals to x byte. So if we perform simple cross multiplication, then x byte will equals to 64 divided by 8. Now if we should perform this simple calculation, you get 8. Now 8 represents the size of each element, and this is the item size, but we'll come to that later. But to get the total size, we multiply it by 4 because we have 4 elements in A1. So we got 32, and that is how nbyte came about with this 32. Now let's look at item size. Item size is very similar to nbyte, but it returns the size of each item in an array. So let's run this. So we got 8, and it corresponds to this 8, which is the size of each item. We have looked at those array attributes that are used to gain insight from our array. So now let's look at those array attributes that we can use to manipulate our array. I've created these two arrays to use for explanation. First, let's take a look at our first array. So this is our first array. It has 2 rows and 4 columns. The first attribute I want to look at is .t. This .t stands for transpose. It can be used to convert rows into columns and columns into rows. This array now has 2 rows and 4 columns, so we can use .t to convert it into 4 rows and 2 columns. So let's do that. So we are slowly converting into 2 columns and 4 rows. Now let's look at our second array. Our second array has 3 columns and 4 rows. So we can transpose this using .t. So our transposing it, we got 3 rows and 4 columns. We can also use np.transpose for this. p.transpose. Then passing. So we have achieved the same thing using np.transpose. Let's look at .reshape. .reshape is an array attribute that helps to change the size of axis of an array or the shape of an array. Let's say we want to change the shape of this array. Now this is a one-dimensional array. First, let's look at the array. This is the array. Let's look at its shape. It has a shape of 12 by 0. This is because it's a one-dimensional array. Now let's say you want to reshape this array to 6 by 2 or 4 by 3. Let's reshape it to 4 by 3. So you reshape version 4 by 3. Let's save it to an. So you now got array that has 3 columns and 4 rows. Let's look at each shape. So you got array that has 4 by 3 shape. Now we have worked with a one-dimensional array. Let's see how to change the shape of a two-dimensional array. Let's look at the array first. So we have a two-dimensional array that has 3 columns and 4 rows. Let's look at each shape. So it has a shape of 4 by 3. Now let's change this shape to 6 by 2. Specify 6 and 2. So we now got array that has 2 columns and 6 rows. Let's look at each shape. So it now has a shape of 6 by 2. So that's it with reshape. Resize attribute is similar to reshape attribute. They perform the same function, but the difference is that resize attribute alters the original array, while reshape creates a new array. Let's perform concatenation and stacking. Both concatenation and stacking are used to combine two or more arrays together. Now, let's combine these two arrays using concatenation. So to do that, we use np.concatenate. Then we pass in a1 and a2. Let's name it JC. And then print it out. So let's run. So we got 10, 50, 60, which corresponds to the first array. 100, 200, 300, which correspond to the second array. So now let's perform stacking. Stacking is similar to concatenation, but the only difference is that stacking is very flexible and comes in different flavors. We can stack horizontally or on the x-axis using hstack. We can stack vertically using vstack, and we can stack on the z-axis using dstack. So let's stack horizontally using hstack. So we run. So we got this. It's very similar to concatenation. So now let's perform vstack. So vstack stacks it or combines the two arrays vertically. So let's start using this stack. This stack combines the array on the z-axis. We have looked at concatenation and stacking. Array split is the opposite of concatenation. While concatenation helps us to combine multiple arrays into one array, array split helps us to split one array into multiple arrays. Now let's say we want to split this array into 3 different arrays. We will use np.array split, passing the name of the array and the number of arrays you want to create. Now let's save it to an. Let's print this out. Let's run. So we got 1, 2, 3 arrays from this one array. Let's look at append and delete. Append is used to add elements to the array, while delete is used to remove elements from the array. Now I've created this array of 0, 1, 2, 3 to 5. Now let's say we want to add 6 to this array. Can use np.append, pass in the name of the array, and then pass in the number we want to append. Let's save this to ap and let's print it out. Right. So we got 0 to 6 now. You can see the 6. Let's want to add 6, 7, 8. You can pass in a list here. 6, 7, 8. So you can see 6, 7, 8 added to it. You can also delete from the array. Let's want to delete 0 from the array. So you can replace append with delete. Remove this to 0. So you have deleted 0. Now let's want to delete 0 and 1. So you can pass in a list 0 and 1. So you now started with 2. So we have deleted 0 and 1. We have covered a lot. So now let's see how to select elements of an array. To select elements of an array, we can use indexing or slicing. Now I've created these 3 arrays to use for explanation purpose. This one is a 1-dimensional array, this is a 2-dimensional array, this is a 3-dimensional array. So indexing, the way indexing works is that it makes use of the fact that each element of an array has a unique index. For instance, the 1-dimensional array, this 2 is on the first index, the second index, the third index. The first index is 0, the second index is 1, the third index is 2, and it goes on like that. So let's see how I perform indexing on a 1-dimensional array. So first, you write the name of the array and then a square bracket, and inside the square bracket you specify the index of the number that you want to select. Now let's say we want to get 2, so we just specify 0 here. This is because 2 is on the 0th index. So we run. So we got 2. Now let's say we want to select 6. 6 is on 0, 1, 2. So we write 2 here. So we got 6. Let's say we want to get 14. We use 6. So we got 14. You can also use -1 to access 14. So we got 14. Let's say we want to get 12. You can use -2 to get 12. This 12 here. So we got 12. Now let's see how to work with a two-dimensional array. Two-dimensional arrays are slightly different from one-dimensional array in the sense that two-dimensional arrays are made up of one-dimensional arrays. So if you look at this two-dimensional array, you see that this one is a one-dimensional array and this other one is a one-dimensional array. So first of all, you have to consider the index of these one-dimensional arrays before you then consider the index of their elements. So let's say we want to get 4. So first we have to consider the index of the array in which 4 is present in. So first, this one is on the 0th index, so we write 0, and then we then consider the index of 4, which is 0, 1. So we got 4. Let's say we want to get 14, we use -1. So we got 14. Now let's say we want to get 2, which is on this other one-dimensional array. So the other one-dimensional array is 1. Is present. The index is 1, and 2 is on the 0th index. So we use 0. So we got 2. Let's say we want to get 12. I'll use -2 for that. So we got 12. Now let's see how to work with a three-dimensional array. A three-dimensional array is made up of two-dimensional arrays. So first of all, you have to get the index of the two-dimensional arrays. This is a two-dimensional array, and this is another two-dimensional array. So you have to get the index of the two-dimensional array, and then you get the index of the one-dimensional arrays present in the two-dimensional array before you then get the index of the element present in the one-dimensional array. So let's say we want to get 4. This 4 is present in this two-dimensional array. So first, this two-dimensional array is on the 2nd index, or the index number is 1, and the 4 is present on this one-dimensional array, which is the 0th one. So we use 0, and the index of the 4 is 1. So let's run. So we got 4. Now let's we want to get 14. You can use -1 for that. So we got 14. So that's how to work with indexing, or that's how to perform indexing. Let's look at array slicing. Array slicing helps us to return range of values, or helps us to select range of values from an array. So let's say we want to select 468 from this one-dimensional array. So first we write the name of the array, square bracket. Now the index of 4 is 1, and the index of 8 is 3, but we use 4 because this 4 will be exclusive and is going to stop at 3. So you got 468. Now let's want to select everything from 4 till the end. So use this, use 1 and colon. So we got everything from 4 till the end. Now let's want to return all the elements present in this array. So we just use only colon. We are able to return all the elements present in the array. Now let's see how to work with, or how to perform slicing on a two-dimensional array. Now a two-dimensional array is made up of one-dimensional arrays. So first you have to consider the index of the one-dimensional arrays present in the two-dimensional array. So let's want to select 4 from this two-dimensional array. So first we will consider the index of this one-dimensional array, which is 0, and then the index of the 4, which is 1. So we got 4. Now let's want to select 2 from this other one-dimensional array, which is present in this two-dimensional array. So this one-dimensional array is present at index 1. and the 2 is at index 0. So you got 2. Let's do something else. Let's say we want to select 2 from the both arrays. So with that we use colon, then comma, and then specify the name or the index of 2. Now this column will help us to select both index, and then the 0 will help us to select the 0 index of both arrays. Now let's run this. So you got 2 2. Now we can select 468 from both arrays by using 1 to 4. Let's run. So you're able to get 468 from the both arrays. Let's see how to perform some basic math operations with Numpy. Now let's want to add 5 to every element of this A1 array. To do that, we write the name of the array and then plus 5. So we got 6 here. 5 plus 1 is 6. 5 plus 2 is 7. So let's want to subtract 2 from every element of the array. Subtract 2. So we got minus 1, we got 0, we got 1. Let's want to multiply everything by 10. So we got 10, 20, 30, 40. Now let's want to square every number or every element. So we got the square root of 1, square root of 2, square root of 3. Now let's find the square root of every element, though this may be unnecessary, but let's just do it. Then pass in the name of the array. So we got the square root of every element. Now we can also add 2 arrays together. Let's want to add the element of this array to the element of this array. So we can do that. So A1 plus A2. So we got 7, 1 plus 6, 7, 2 plus 7, 9, 3 plus 8, 11. We can also perform subtraction. So let's change this to minus. We got minus 5, minus 5, minus 5. Now let's change this to 2 and this to 1. So we got 5, 5, 5, 5, 5. You can also multiply them together. So we got 6, 2 times 4, 2 times 7, 14, 3 times 8, 24. You can also perform division. Let's divide A2 by A1. So we got 6, 3, 2, 2, 2, 1. So I believe that's enough. Let's look at statistics with Numpy. Statistics with Numpy. Let's look at measure of central tendency like the mean and median. I'm making use of this array. Now to calculate the mean, we use np.mean and then pass in the array. So the mean of this array is 63. Now let's see how to calculate the median. To calculate the median, we just change the mean to median and run. So the median of this array is 78. Let's look at measures of spread like the range, interquartile range, and standard deviation. Now the range is the difference between the maximum value and the minimum value. So to calculate the range, we have to calculate the maximum value first and then the minimum value and then subtract them to get the range. So to calculate the maximum value, use np.max, then pass in the name of the array, then main np.mean, pass in the name of the array, then range equals max minus mean, then we print it out. So our range is 97. So now let's look at interquartile range. interquartile range is different between the third quartile and the first quartile. So first, let's calculate the third quartile. So to do that, use np dot quantile, pass in the name of the array, then 0.75. Now let's calculate the first quartile, np dot quantile, the name of the array, and 0.25. Then IQR, which stands for interquartile range, equals Q3 minus Q1. Now let's print it out. IQR. So you got interquartile range of 56. Now let's look at how to calculate a standard deviation. Let's call it std equals np.std. We pass in the name of the array. Let's print it out. So you got a standard deviation of 34.67. Let's see how to use Numpy to calculate measures of partitions or quantiles. So we will look at quantiles, decile, and percentile. Oh, this is not properly spelled. So first let's look at the first quartile, which is Q1. To calculate it, we use np.quantile, then the name of the array, and 0.25. Now let's print it out. Q1. So our first quartile is 35. Now let's calculate our second quartile. Let's call it Q2. And let's turn this to 0.5. Now let's run. So our second quartile is 78. Let's calculate our third quartile. And let's turn this to 0.75. Let's run. So our third quartile is 91.5. Now let's calculate our decile. Deciles are those numbers that divide our data or our array into 10 equal sizes. So to calculate deciles, let's call it deciles. Deciles. We do np.quantile, then the name of the array, and then the list of the numbers that are going to divide our array into 10 equal parts. Now let's print out our deciles. We got to 7.5, 14, and all this. So these are the deciles. Now let's look at our percentiles. Let's just call it PEC. Let's want to calculate the 30th percentile. So you replace this by 0.3. So these are 30th percentile. Now let's want to calculate our 40th percentile. Change this to 4. So we got our 40th percentile. So percentiles are those numbers that divide our data set or array into 100 equal sizes.